Row 1. Text, Notepad window, text editor, editing. Remember, this is not teaching man teacher. It's selected blank. It is useful for recalling when exam coming man student. Just selected. Close eyes. Space. Just. Based on G scheme for Electronics Engineering Group. Subject, Digital Communication, 17,535. These are mostly important questions which is always repeat. Form top to end it, reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Digital Communication Chapter 6. 1. 1. Compare DSSS and FHSS System W.R.TI, Definition 2. Chip Rate 3. Modulation Technique 4. Effect of fading ANS, each correct point 1 mark. 2. What is maximum length sequence? Generate maximum length sequence of length 7 with feedback taps equals 3, 1. ANS, a PN sequence, is defined as a pseudorandom coded sequence of ones and zeros with certain autocorrelation properties. Maximum length of PN sequence L is the no of bits in a PN sequence, and it depends upon the number of flip-flops N used for the PN sequence generator, and given as L equals 2N1, 1 marks. The block diagram for 3-bit, that is 7-bit length of PN sequence generator is as shown with feedback taps 3, 1. Let initial O/P equals 100, any initial value can be taken, table is as shown below. Digital Communication Chapter 6. 2. 3. Draw the block diagram of a BFSK/FHSS transmitter and explain its working. State any 2 advantages. ANS. Block diagram of a BFSK/FHSS transmitter. 2 marks. Data BT, mixer FHSS signal. Explanation, 2 marks. The binary data sequence is applied to the M-ARRI FSK modulator. The output of M-ARRI FSK is mixed with the frequency synthesizer output. The frequency synthesizer decides the hopping patterns of the system. The output of mixer is the stream of 2 frequencies. Sum and the difference of both the inputs to it. The frequency of the mixer input obtained from MFSK modulator is changing continuously. Other input to the mixer is obtained from the digital frequency synthesizer. The synthesizer output at a given instant of time is the frequency hop. Frequency hop at the output of synthesizer are controlled by the successive bit at the output of PN code generator. The band pass filter is centered at the sum frequency band and rejects all other components. This sum components of the frequency are then retransmitted as FHSS signal. In slow frequency hopping, the symbol rate RS of the MFSK signal is an integer multiple of the hop rate Rn, that means several symbols are transmitted. Corresponding to each frequency hop. Each frequency hop, several symbols here. Frequency hopping takes place slowly. Advantages, any 2 to 2 marks. 1. The synchronization is not greatly dependent on the distance. 2. The serial search system with FHSS needs shorter time for acquisition. 3. The processing gain PG is higher than that of DSSS system. Digital Communication Chapter 6. 3. 4. Draw and explain the block diagram of DSSS-based CDMA system. ANS. Diagram 04M DSSS-based CDMA system. Explanation. 04M, if with all its huge transmission bandwidth, if a DSSS system can serve only one user, it will be indeed a waste of bandwidth. DSSS systems can in fact provide multiple access, i.e. allow multiple users. This multiple access facility is called the Code Division Multiple Access, CDMA. It has certain advantages over the other multiple access facilities like TDMA, FDMA. It does not require any bandwidth allocation, as in FDMA, or any time allocation as in TDMA. In CDMA, using DSSS, each user is provided with a unique PN code, and the PN codes given to different users are almost uncorrelated. All the users in CDMA use same carrier and may transmit simultaneously. Each user has its own pseudo-random code word, which is orthogonal to all other code words. For detection of message signal, the receiver needs to know the code word use by transmitter. Each user operates independently, with no knowledge of other users. Fig above illustrates the principle of CDMA based on DSSS. Digital Communication Chapter 6. 4. 5. List out application of spread spectrum system. ANS, any 4, 1M. Each applications of spread spectrum are 1. Military application, resistance to gaining. 2. CDMA and satellite communication. 3. Police radar can employ spread spectrum to avoid detection by detectors employed by drivers. 4. Low-density power spectra for signal hiding. 5. Multipath rejection in a ground-based mobile ration. 6. In local area network. 7. In global positioning system, GPS. 6. Explain fast frequency hopping with suitable diagram for MANS. Fast frequency hopping means multiple hops are used to transmit one symbol. Thus the hop rate RH is higher than RS. The chip rate is equal to hop rate RC equals RH. The figure shows variation of transmitted frequency of fast hopping with time. Digital Communication Chapter 6. 5. 7. Draw block diagram of PN sequence generator using 4D flip-flop. For MANS, where X1, X2, X3, X4 are D flip-flops. A PN sequence is defined as a pseudo-random coded sequence of ones and zeros with certain autocorrelation properties. Maximum length of PN sequence L is the no of bits in a PN sequence, and it depends upon the number of flip-flops N used for the PN sequence generator, and given as L equals 2N. 1. The block diagram for 3-bit that is 7-bit length of PN sequence generator is as shown with feedback taps. 3. 1. Let initial value of shift register output, i.e. Q3, Q2, Q1 equals 001. Any initial value can be taken. Table is as shown below. The actual data repeats again and again, as shown in above table, with pseudo-random data bits in between to improve security of the data. Here the PN coded data will be of 7-bit. The PN sequence obtained at the output Q3 of flip-flop 3 is 001011100010. Digital Communication Chapter 6. 6. 8. Explain fast frequency hopping with diagram. For MANS, fast frequency hopping. In fast frequency hopping, multiple frequencies, or hops, are used to transmit one symbol. That is, each symbol, several hops takes place. So several frequencies changes for one symbol such that symbol rate RS hop rate RH.